Welcome back, everyone. Today we're going to do something I haven't done in years. I'm starting up the old Universe Sandbox, um, and we are going to specifically look at what would happen if Ceres, the largest asteroid in the asteroid belt and the nearest dwarf planet, crashed into Mars. Okay, and just so y'all know, honestly, I haven't done one of these in ages because I don't like the new format the Universe Sandbox is using. I much prefer the older format. And I just recently discovered how to go into properties, select beta, and then select the version of Universe Sandbox that you like. So just bear with me as I'm trying to recall from about 7 or 8 years ago, I believe, what the layout of everything is. So I'm a little rusty, just bear with me. I need this to not orbit, I need it to just fall towards Mars, and preferably from a distance of about where the moon is to Earth, because at 1/10 the mass of Earth, that's about as far as Mars is going to be able to hold on to anything. And I honestly doubt, so yeah, we're going to shoot for 400,000 kilometers. I honestly doubt it could hold on to a moon that far away at 1/10 Earth's mass. Um, well, yeah, we'll give it a shot. We'll see what we can see. Now, for the first, I really hate that galaxy in the background. That's really makes it hard to see everything. It's real pretty when you're close up, but my God, when you're trying to looking for just stars, when you're trying to see really small things in the distance, it just blinds you. Where is it? There's one of these that's just stars. You can just completely get rid of the. There we go. Okay, you just completely get rid of the Milky Way. So that's much easier to see. Oh, you got a nice little shadow from Ceres. Now, of course, this is just a universe with Mars and Ceres. So the lighting and of course the shadow is artificial. There's no actual sun in this star system. We're just playing with these two bodies right here. But you'll notice how Ceres was dry, right? Like it didn't have any water to it. We actually want to set that to about 25%. That's about as close as I'm going to get to 25%. And if I do a couple of these, I'm going to point out where Universe Sandbox is wrong and has been wrong for a decade on a lot of these little factoids. Like for instance, everybody knows Jupiter's moon Europa hides a liquid ocean underneath, but according to Universe Sandbox, it does not. It's solid silicate. So we all know that's not true. We can clearly see there's ice on the surface. Even if there is no ocean, there's a lot of ice on the surface. So, but yeah, what's going to separate hopefully me from a lot of the other YouTubers that do this, and I don't want a super fast approach, just trying to get it closer. It's falling towards Mars, which would simulate about as slow an approach as you can get, because for some reason, if we were able to maneuver Ceres near Mars, gravitationally, it's going to accelerate Ceres as if they were two stationary bodies falling towards each other. So, of course, Ceres is pulling on Mars a little bit as well, slowing it down. So, I can't remember off the top of my head how quickly Mars moves around the sun, but yeah, we're going to have a nice little impact here. But yeah, what I was saying is, and there's a nice little size comparison. What I was saying is, a lot of YouTubers, they just smash things together, and they don't really have the knowledge of, what would actually happen. Are these estimates of their composition accurate, and what the differences would be? So, boom, we get a nice little impact there. All right. And these are older graphics. I mean, I've seen the new graphics. They don't really appear that much fancier. There's a little more particle separation on impacts and things like that. Now, what's happening here is, you can clearly see to put that in Fahrenheit, the surface of Mars is extremely hot. And it's already cooling, though. That's another thing I'd like to say. And see up here, you can see that Mars is now covered with water. I mean, it's a water world, right? Now, it's going to lose a lot of that to space from the impact, the outgassing. We're only advancing minutes per second. So, one order of magnitude faster than reality. Of course, you can see the planet drying up there. Of course, this is not how this happens in the real world, okay? If Ceres were to actually smash into Mars, it would remain extremely hot for years and years and years. It would not just dissipate in less than an hour. That's ridiculous. Things don't move that quickly in the real world. They move, that's why it's called geological time scales, because you're talking in millions and billions of years, or at least 100,000 years. But in Universe Sandbox, I get that it's a game, it's a sandbox game. I'm not trying to be overly critical of it, but this helps give people the false impression that if you were to give Mars or the moon an atmosphere, that it would just fly off into space. You hear that all the time. Mars doesn't have a magnetic field. The moon doesn't have a magnetic field, so it would just fly off into space. And sure enough, Universe Sandbox is showing you that it just flies off into space. And this is not the case at all. Planets have gravity. The solar wind does strip a small amount of particles over time, but the more atmosphere you have, the harder it is for the sun to strip that atmosphere off the planet. Now, you might have more overall loss because there's more air to lose, but all you have to do is look at Venus, right? Venus is clearly a world, and you can see here, I'm bringing up the numbers, right? Mars is actually, in this simulation, has lost atmosphere because a Martian atmosphere should be exactly 1. So the impact cost Mars about 25-30% of its atmosphere. Of course, it's nothing. If this measured in Earth atmospheres, it should be 0.07%, because there's 7 thousandths of a percent, so less than 1% of Earth's atmosphere. But yeah, surface temperature is still extremely hot. I was saying, all you have to do is look at Venus. Venus has no magnetic field, but it has an incredibly dense atmosphere. It's 90 times thicker than Earth's atmosphere, which means there's 90 times as many atoms and molecules in Venus's atmosphere as Earth's. Popular quote is that the surface of Venus, the pressure on the surface of Venus, is equivalent to being 1 mile below the ocean on Earth. That's how much pressure would be bearing down on you on the surface of Venus. In fact, its atmosphere is so thick that you can't even really crash into it. You don't even need a parachute, because I think your maximum impact speed is about 25 miles an hour. 25 miles an hour. It's something pathetic because there's so much air. It's literally like you're sinking into the ocean. You reach a much lower, what's called terminal velocity, your maximum fall rate, because of all the drag of the thick atmosphere. So, yeah, you can actually land a spacecraft on Venus. You can slow it down with an initial parachute, but you don't need a parachute for like the last 40 kilometers of atmosphere, something like that. So don't quote me on that. That one I'm a little fuzzy on. Okay, now on this simulation, to get like a more accurate simulation, what I'm going to do here is I'm going to keep the radius of Mars the same, so that 3390, okay? But we're going to up the mass of the Earth to 1. So we're going to make it more massive, right? Much more massive, 10 times more massive, right? But we're going to lock that radius the same because we want to see how much water Ceres will leave on the surface of Mars. if it is 25%. Now the reason I'm going with 25% is that is our best guess. Even after sending the Dawn spacecraft to Ceres, we still don't know how much of Ceres is actually water ice. And the best estimate we have is about 25%. But, there's a big but. Um, somebody just released a research paper that, based on the Dawn spacecraft information, I'm just going to get this to 25% real quick. Based on data from the Dawn spacecraft, they estimate that Ceres could be as much as 90% water ice. That what you're seeing on the surface is dark color is nothing more than a dusty, residue that's accumulated on the surface. And there is evidence to support that. I mean, Ceres is very, very smooth. It doesn't have tall mountains. It doesn't have very deep craters. It's a little rougher than this model in Universe SANDBOX shows, but here we go with another simulated impact. This time, Mars will be able to hold on to the atmosphere in a more realistic way because I increased its mass. But the reason like I said, the reason I kept the radius, the size of Mars the same, is we want to see how much coverage we get with this water. You can already tell there's not the wild outgassing that you saw in the last explosion. So I didn't move Ceres out to 400,000 kilometers. That's my bad. I'll have to redo a more accurate one just to see if we get that massive outgassing effect. But yeah, what you are seeing, that pale blue, is ice. And I changed the surface temperature to 17 Celsius, which is about room temperature for Americans. That's about 65 Fahrenheit, something like that. So just for an American audience, I'm American myself. I'm one of you guys. 0 Celsius is freezing, 100 is boiling. So in Fahrenheit, that's like 212 is boiling, and 32 is freezing. Okay. So yeah, the simulation's taking a while to catch up. I'm gonna speed it up a little bit because it should not be frozen at room temperature, but it takes a little while for the simulation to catch up. I've got we're only passing 17 minutes of real time per second, so just give it a minute. It will thaw out. I'm also pumping up the atmosphere to about 40% Earth's, which is a little better than what you find on Everest. That's about the bare minimum of what you would need for humans to comfortably breathe. You don't actually need, and there you see, you got a lot of coverage on this ocean. You don't actually need a full bar of air pressure. That's a myth. You do need a little bit more than what hikers on Mount Everest take with them, or what they experience. But they breathe pretty much pure oxygen at the peak, so that helps with the much lower pressure. But humans, especially in a lower gravity, without all the weight bearing down on you, man, this ocean's huge. Without all that weight bearing down on you, you wouldn't need but at the most, really, 40% Earth's atmosphere. So, like I said, if people can survive with about 0.3 bars, if they can survive, 0.4 in lower gravity should be more than adequate, especially if you're talking about pure oxygen. Right now, you and I are breathing, 78% nitrogen, and our body can't do anything with that. So we breathe it in, it's useless, it's totally inert, and we have to breathe more because we need that oxygen part. Man, look how massive this ocean is. I think that's Hellas Planitia there, that huge circle of water. So you got Valles Marineris there, obviously. That's a very discernible feature on Mars. It's really beautiful too. There's Olympus Mons, of course. Olympus Mons, just you know, fun fact there. Olympus Mons will be the absolute last thing to go underwater if we could just magically dump water onto Mars. But yeah, I'm fairly sure this is Valles Marineris. I'm gonna take the water away briefly, just to make sure. Yep, it sure is. See that discolored area, the lighter area right there? That's Hellas Planitia. That's one of the biggest impact craters in the universe, in our solar system. It's about 7 kilometers deep, and it's my personal favorite place to colonize and begin terraforming Mars. That's going to about wrap it up for this video. Listen, y'all, I hope you all enjoy this. If you want to see more of this more casual, laid-back format, let me know. And please let me know what you'd like to see next. I'm up for suggestions. If you got an idea, let me know what you want to see next in Universe Sandbox. Take care.